Hello, very warm welcome to the teachers and other people watching the video. Today I'll be presenting a video on data forensic and computer forensic, and today I'll be showing a demonstration of steganography, that is data hiding in an image, which can be in any format, like in a text, audio, or in video format. And today, and for the other tasks, we have to use data hiding in a Slack space, and we will also use some of the anti-forensic techniques and its applications for it. So first, if I've used my OpenPuff software for that, um, for using my steganography technique. And what is actually, I've told you about steganography. So I've used OpenPuff software for it, which has various advantages, like it is professional, so it can be used at various places, and it is support various formats like BMP, JPG, PCX, PNG, and it also audio support, video support, Flash Adobe support, and OpenPuff is also portable stealth software, which is runs in user mode with DEP, or OpenPuff is safe, which is like a spyware and free, fully discover OpenPuff core and crypto library. Now, if you want, I'll show you the steps of performing a steganography. So for that, I have created a steganography folder in the desktop. Um, yeah, this is where it is, and in this folder we will create two files, that is a confidential data, and then the other one is going to be an image file. In this confidential data file, we will create a confidential data that we want to store in. For in our case is our student ID. This is our student ID that we are storing in, and this is going to be the image. We can take any image for that, but 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 we have, when we are showing the data in the image, we have to take care in the mind that the size of the image, size of the text should be smaller than the size of the image. So our size of the text is 13 bytes, whereas the size of the image is yeah, so our size of the image is 133k, 13k bytes. So yeah, so the size of the image is 12k, 12 KB. So which is larger than the size of the confidential data. And for that, I will use an OpenPuff software for that. Yeah, which is I've already downloaded an OpenPuff software. Will ask me to download it again, but I've already done. So I'll show you my demonstration. Yeah. So for then we will create a steganography folder, then go to confidential data, then store a hide. Then this is the screen that will appear on the screen. Then we'll click on hide option. Then clicking on hide option, it will ask you if you want to keep a password or how long the password is, because when you send the data to a person, so that data should be secret data, so that should have some password or stuff for it, so that the other person who want to open cannot see the data inside it. So the other person should have the same software who is using, who wants to unhide the data. So for that, we will keep a password and we'll send the password to the person who wants to unhide the data. So for that, this is the password that we have kept, and then we will add an image on it. Then we want to hide the data in it. So in our case, I've selected that steganography folder and then gone to the image and selected the image. Then for the other, we have created another folder where we want to hide that secret data in it, like the image in it. So for that, we have created another folder called hidden folder in the desktop. And then we have selected the data from clicking on browse that we want to hide in, and then click on add or hide data. So it will say 101 proceed. So this is the report that the data is hidden in it. This is what is going to be appear at the end, that this is done. So then now we will go on the second task, that data hiding in a Slack space. So first of all, what is Slack space? The file system uses blocks to store data in certain size units. Blocks are the smallest size of unit. Like if we have a notepad or MS Word where we have a header and footer in it. So if we write some data and other stuff in it, there will be some space left in header and footer. So that space in it is can be considered as slack space. So we can hide our data in it. So two mutually exclusive functions can arise when the data is stored in the block is filled or the block is partially full. That is what it means. So for hiding the data in slack space, I've used bmap. Bmap is a tool for constructing a file block map. This has various advantages like it is faster, it uses integrity, it checks data integrity while flashing, it is usability, it can read photos directly from a remote server, and it protects data from the user. Like unlike DD, if you supply the endorsed block device name, Bmap tool is less likely to corrupt your data. So for hiding data in a Slack space, I've used Kali. First of all, we have to go on virtual machine. Then we have to install Kali if it's not installed in a system. Then we have to go on Kali and download the Bmap in Kali. For and then there is a certain specific file that you have to download in Kali, that is bmap slash 1.0.17.tar.gz, that is gunzip file. For downloading the gunzip file, after downloading the gunzip file, you have to untar and gunzip the file. For that, you have to use a command prompt. And then this is a screenshot of how I've done a gunzip file. This is a gunzip command that I've used. Then I have to untar the bmap file. This is gunzip. Then I have to tar xovf, then bmap. Then we have to change the directories and then go to the bmap folder, then compile the file for it. For that, I have to make a symbolic link and then change the directories again. For changing the directory, I have to use the cd command and then use it and change the directories. Then we will use the echo command. So echo command, this is the text we want to store in it. And then we have a certain text that we want to store in it. So we will use a push select command and store the data in it. So for in our case, it is a student ID, that is MIT 210111. I have stored my top secret data and use a push select command in a test file. That is what we have created in our desktop of Kali. For then we'll use the slackS command. Then this is a command where we will see our data is stored. So for the beginning, you can see the file size was 20, slack size of 4076, and block size of 4096. Then we have put in our data. Then file size was 20, slack size was 4096, and this is the top secret data that we have put in a slack space. That is MIT 210111. So this is what it is put in it. And then for checking in it, I've used my ls-l command, and this is going to be the test folder that I have created in the desktop of Kali. So it will display that where the command is in, and it will display the in perfect folder where it is. Then we have other anti-forensic technique that I've used, like data hiding, steganography, algorithm for encryption, rootkits. A rootkit is a term used in malware to describe a type of malware designed to interact a target computer. And for that, I'm using an encryption technique. And these are some of his. Then I've used artifact wiping. This is the some of his application like disk cleaners, free space, and memory cleaners. Then I've used a trial obfuscation. These are some of its application like lock cleaners, spoofing, misconfirmation, zombie account, Trojan accounts. Then attack against computer forensic tool, file signatures, altering, hashing full, nested directories. And I've also used transformation, disk construction techniques, zombie bombs, and these are some of its applications like original image, Tigo image. Then at the end, I've used steganography using Kali. I've also done using Kali. The first I've represented using steganography using OpenPuff tools, and this is the I'm using Kali. Then at the end, I've represented some pros and cons of the technique that I have used above, like encryption techniques. It has an anti-forensic technique that's a great advantage of the odd encryption, that in a disk using a different encryption algorithm, which the disk is impossible to read it without a designated key. And it also has some of its consecutions. Then I use data wiping technique, onion routing. That is a Tor is a best example of onion routing that I've used in it. Then I've used a disk dissection technique. So this is what uh, all about our assignment, and this is what presentation stand. So thanks for watching it, and have a good day.